everyone. Today I'll present our research on modern data leak detection and prevention strategies. As organizations handle ever-growing volumes of sensitive data, protecting against unauthorized disclosure has become critical. We're witnessing exponential growth in data generation across all sectors. Our work addresses the limitations of traditional DLP systems and proposes a novel genetic algorithm-based approach that can adapt to transformed data while maintaining interoperability. This is particularly important as regulatory frameworks like GDPR impose severe penalties for data breaches. The data leakage problem has intensified with modern work practices. Traditional DLP systems rely on static content matching, which fails when sensitive data is transformed or obfuscated. Insider threats account for 60% of breaches. These aren't just malicious actors, but often well-meaning employees who make mistakes. External threats like botnets present new challenges, exfiltrating data in small chunks across thousands of devices. Organizations need adaptive solutions that can handle diverse data flows while maintaining transparency. The financial impact includes direct costs averaging $4.5 million per breach, regulatory fines under frameworks like GDPR and CCPA, and lasting reputational damage that can persist for years. Our survey identified several detection approaches, each with distinct trade-offs. Graph-based methods capture contextual relationships, understanding that confidential near salary has different meaning than those words separately, but have high computational overhead. Machine learning achieves high accuracy but lacks interoperability, which is critical for security teams who need to understand, validate, and explain decisions to auditors or in legal proceedings. Anomaly detection shows promise, but requires extensive training data covering all legitimate scenarios. Context-aware methods are powerful but need constant maintenance. This fundamental trade-off between accuracy and explainability motivated our genetic algorithm approach, which uniquely combines learning capability with transparency. Our genetic algorithm evolves interoperable if-then rules from training data through natural selection principles. Unlike black box models, these rules are human-readable. Security analysts can understand exactly why a document was flagged. The algorithm balances accuracy with rule simplicity, typically converging within 100 generations to find optimal feature combinations. We use a fitness function that combines precision and recall metrics, ensuring we both catch genuine-looking leaks and minimize false alarms. The evolution process discovers non-obvious patterns. For instance, finding that Q3 revenue documents are only sensitive when combined with forecast but not published. This transparency is crucial for regulatory compliance and building organizational trust. We validated our approach on 3 real-world datasets. The genetic algorithm achieved the highest fitness function score of 0.877, outperforming traditional methods. Crucially, it achieved this using only 15 to 35 interoperable features compared to over 1,000 features in black box methods. This demonstrates that evolutionary research can find compact, accurate rule sets. The practical impact extends beyond academic metrics. Security teams can directly implement these rules in existing infrastructure without specialized machine learning frameworks or expensive hardware. The evolved rules align beautifully with human intuition. For instance, detecting personally identifiable information by looking for social security numbers and address patterns while intelligently excluding test data marked with example or demo. The method shows particular strengths with imbalanced datasets, reducing the false positive fatigue that overwhelms security teams. Rules can be manually adjusted as organizational policies change. If new regulations require protecting additional data types, analysts can add rules without retraining. This adaptability, combined with transparency, makes our approach particularly valuable for organizations facing evolving compliance requirements. Looking ahead, we envision extending this to an adaptive ensemble framework where the genetic algorithm serves as an intelligent orchestrator for multiple detection modules. By dynamically adjusting weights between anomaly detection, context analysis, time-based scoring, and dynamic deception models based on real-time feedback, organizations can maintain effective protection without constant manual tuning. This addresses the fundamental limitation of current data leak prevention systems. In conclusion, our genetic algorithm approach successfully balances accuracy with interoperability, providing a practical solution for modern TLP challenges. We achieved the highest fitness function score while using 30 times fewer features than black box methods. The human-readable rules, deployment simplicity, and adaptability make this a significant advance in data protection. Thank you for your attention.